students, now I think it's a time that we should continue with question number 29. Let me first of all make you read the question. Give me 1 sec so that I can show you the question. Yes, so question number 29, coming to this question. The question says that the reagents which can be used to bring about the following transformations is or are. So you have one transformation where the COH part is same, epoxide part is same, whereas the aldehydic part has been converted to alcohol, and C double bond O, every part is same. Now you have to select which will be the best reagent, whether it is LiAlH4 in C2H5 twice O, which you can be using for this particular conversion, or you have borane in THF, or you can be using NaBH4 in C2H5OH, or you can be using Rene-nickel in the presence of hydrogen in THF. So let me first of all write down this question, and I'll tell you some facts which are very, very important for this particular question. So yes, let me write down. This is question number 29. And this question number 29th, it says that, let me first of all tell you what are the problems with all these reagents and how am I going to choose all these reagents specifically for this particular reaction. The first is you have LiAlH4 in C2H5 twice O. Then you have BH3 in THF, and if I take Rene-nickel in the presence of hydrogen. Now one important fact regarding all these three reagents that we have been using is that either they can reduce all the functional groups or can reduce some of the functional groups of the compound given in the reactant site. So the very basic thing is we should not be using that particular reagent which will be reducing all the functional groups, because it is very specific. I told you that there is only one particular group, COH, which I want to be reduced to CH2OH. Now, so if I keep all these things aside, but if I take into account NaBH4, this is a very, very good example of selective reducing agent. So this is selective reducing agent. Now this cannot reduce ester, C double bond O, so this ester bond will be as such, so ester group will not be dissociated by this. Moreover, the carboxylic acid group COOH, this even won't be affected. So again we are on the safer side with this, we are on the safer side with this also. Moreover, if I keep on talking about the epoxide bond, this epoxide bond will also not be cleaved, and hence we are on the safer side at this position also. But if I take into account the aldehydic group, the COH group, this will be reduced into primary alcohol, which is CH2OH. And hence we can say that you should have only and only option number C, which will be the correct option for this particular question, since we are done with this thing. Now, having done with question number 29th also, it's a time that we should continue with question number 30th. Okay, so to move over to question number 30th. Again, first of all, it's a time that I should show you this question. Now, question number 30th, if you people have to read. The question says, mixtures showing positive deviation from the Raoult's law at 35 degrees C is or are. That means you have to talk about all those mixtures in which you have to show the positive deviation from Raoult's law. So let me tell you one again very, very important thing. So first of all, I think you people would have read the examples. The examples are carbon tetrachloride in the presence of methanol, carbon disulfide acetone, then you have benzene and toluene, and finally you have phenol and aniline. Now, how can we say or how can we justify the answers? Listen to me very carefully. Since I'm talking about positive deviation, now this positive deviation basically says that suppose if you have taken the solvents, let's say AA, and let's say there was another solvent BB, Now what the fact is, if I am not mixing the two, then whatever will be the force of attraction between AA molecules and whatever will be the force of attraction, let's say, between BB molecules, and if I am mixing the two, so we will have both AA as well as BB in picture. Now whatever will be the force of attraction between these molecules, if the total force of attraction between reactants is found to be very equal to the total force of attraction between the product side, you can say that there will be no deviation, or else you can say this is the ideal condition that you have got. If however I say that the force of attraction in these molecules is lesser, so what I'm saying is, if the force is lesser and let's say this force of interaction is more, so you can say that for AA or for BB molecules to get vaporized will be very difficult, and hence the vapor pressure will be reduced. But it will be showing a negative deviation. We are not concerned about negative deviation. Rather, we are concerned about the positive deviation. Now, the positive deviation from Raoult's law is possible when the force of attraction between A and B molecules will be less as compared to that between A and A plus that between B and B. Then only you can say the vapor pressure will be more in this case, and hence they will show the positive deviation from Raoult's law. Now students, based upon all these facts that I have told you, this interaction, whatever I was talking about, this interaction can be taken either in the terms of, let's say, hydrogen bonding. So you have to justify whether hydrogen bonding was more in the initial case or hydrogen bonding is more in the final case. So on the basis of this, let me tell you, now I'll be speaking out, like we'll take into account all the options. So let me first take option number A. Option number A says that you have CCl4 and then you have methanol, CH3OH. So we can say that earlier when methanol was present alone, there must have been hydrogen bonding. But when CCl4 is added to methanol, the hydrogen bonding will be lost, and hence force of attraction will be less, but it will be showing a positive deviation. So we can say hydrogen bonding of methanol will break when CCl4 is added, so the bonds become weaker, resulting in positive deviation. So A is the correct option. Coming over to option number B, this is carbon disulfide and acetone. So we can say mixing of a polar and a non-polar liquids will produce a solution again of weaker interactions leading to positive deviation. Again you can say here I am mixing one polar substance and another non-polar substance. So this is also a positive deviation. The third says that benzene and toluene. Benzene and toluene you must have studied in very previous classes, as this is an example of ideal solution, so this will not be the answer. And option number D, if I say phenol and aniline. When phenol is added to aniline, so you have OH and then you have NH2. Now there will be a strong hydrogen bonding that will be resulted in the final formation, and hence you can say that this fourth D option is also not the correct, because it will be showing us a negative deviation. So students, this was all about question number 30th. Now it's a time that we should move over to another question. This another question that I'll be talking about is question number 31. So to write question number 31, let me ask you to read this question first of all. The question says that the nitrogen compound produced in the reaction of HNO3 with P4O10. That means you have to find out what should be the reaction between HNO3 and P4O10. Now you have to determine the options. Can also be produced by the reaction of P4 and HNO3, or is diamagnetic, or contains one NN bond, or it reacts with sodium metal producing a brown gas. Now let us start to work out with all the single options that have been given so as to come at the correct option. Let me start writing. So very first equation that we should know is P4O10 should be reacting with HNO3. This is what has been given. So this will form HPO3 and it will be forming N2O5. That means the nitrogen compound I'll be talking about is N2O5. If I ask you to balance this, this will be 4 times HNO3 and if you will be doing the dehydration, so what is happening is dehydration of HNO3. Now in this case you will be getting 4 molecules of HPO3 and there will be 2 molecules of N2O5 which will be produced. Now this is the required product. Now let us try to figure out which options are correct. Option number A says that whenever you react P4 with HNO3, let's say 20 moles of HNO3 will be required to react with P4. This will be forming H3PO4, it will be forming NO2 plus it will be forming water. But the product we never got N2O5. That means I can say option number A is not the correct option at least. Now if we go for option number B in this case, option number B says that N2O5 is diamagnetic in nature, and that's a well-known fact. The structure of N2O5 will be something like this. Okay, let me draw the structure. So you have N double bond O and then you have O. It should be forming a bond with O, so it should be like N, and then you should have double bond O and then you have O. That means there will be no free electron, or let's say no unpaired electron will be present, and hence you can say it will be diamagnetic in nature. So option number B is correct. If I ask you to look for option number C says that it contains one NN bond. So again option number C is not correct because there is no NN bond. So C is not correct. And again if I ask you to come over to the last option, which is option number D, it says that sodium will react producing a brown gas. So sodium is going to react with N2O5. Again, this is a good thing because sodium will be forming NaNO3 and it will be forming NO2. Now NO2 by nature is brown in color, and hence we can say that option number D is also correct. So for this multiple let's say correct answer questions, option number B and option number D are the correct options for this particular question. Now students, having done with question number 31, it's a time that I should be moving over to question number 32. Now what's there in this question number 32? First of all, let's read it out. One sec again and let us read this. So question number 32 says that according to the molecular orbital theory, C22- is expected to be diamagnetic, O2 is expected to have a longer bond length as compared to O2, N2+ and N2- have the same bond order, and He2+ has the same energy as two isolated helium atoms. So again my dear students, this all is about how are we gonna decide the answers on the basis of molecular orbital theory. So again I am left with no other option but to start up with the first option. So the first option says that C22- is expected to be diamagnetic. Let us check this out. The molecular orbital energy configuration, I would first of all write down the molecular orbital energy configuration for C22-. So this will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px is equal to pi 2py. So we have to fill 2 and 2 here, and only we are left with 2 electrons. So this is sigma 2pz, again 2. So this is the molecular orbital configuration, and we can say that in the molecular orbital of C22-, as you can see that there is no unpaired electron, and hence C22- will be diamagnetic in nature. So we have arrived at least one of the correct options, option number A. Now it's the time that we should move over to option number B. Option number B says that O2 is expected to have a longer bond length than O2. So it says that the bond length of O2 is longer as compared to O2. Now again the bond order of O2 you will find out. Let's try comparing it on the terms of bond order. You'll find it out as bond order 3, and for this you know that bond order is 2. So this is wrong, right? Because you can say that now if the bond order is more, you can say it will be smaller in length. So I'm talking about the bond will be smaller. So option number B is not the correct option. Coming over to option number C again. Now option number C says that the question is N2 plus and N2 minus have the same bond order. So let me write down the electronic configuration of N2 plus and N2 minus. So this is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Pi 2px will be equal to pi 2py, which will be 2 2, and then you have sigma 2pz1. Now if I ask you to calculate the bond order becomes half number of electrons in bonding molecular orbital, number of electrons in anti-bonding molecular orbital, subtract. So half, you can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 4, which is 5 by 2, nothing but 2.5. And if I ask you to write down the molecular orbital energy configuration for N2 minus, then my dear students, again for N2 minus you will be writing it as, since now N2 minus will have how many number of electrons? It will have 7 plus 1. So it's 14 plus 1, 15 electrons. So the energy diagram that will be followed is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, which will be equal to pi 2py2. So again we can say sigma 2pz2, then you have pi star 2px, which will be equal to pi star 2py, and this will be 1 in this case. So any one of the two will get filled up. And if I ask you to calculate the bond order again, the bond order, this was for N2 plus, and the bond order, okay, this was for N2 minus itself. The bond order will be half into, calculate the two terms, 10 minus 5, again the bond order comes out to be 2.5, and hence you can say option number C is also the correct option for this particular question. Now we are left with just last option, option number D. It says that helium-2 plus has the same energy as compared to the two isolated helium atoms. Now dear students, this is not the case that helium-2 plus will have the same energy. So option number D is also not the correct option. So we, again for this question, we have got option number A as well as option number C as the correct options for this particular question. Now students, since you can see that we have already completed the second section of this complete paper, now it's a time that we should come over to section number 3. Let's see. Yes, so we have section number 3 now. I will ask you to first of all read down the instructions carefully. Once I assume that you have read the instructions, let me now come over to the paragraph questions that I do have. So this set is actually containing 2 paragraph questions. Let's try to figure out all these 2 questions that we are now left up with. Now let us first of all read paragraph 1. It says that the thermal decomposition of gaseous X2 to gaseous X at 298 Kelvin takes place according to the following equation. X2 in the gaseous state is going to form 2X in the gaseous state. The standard reaction gives energy delta G naught of the reaction. For this reaction has been given to us as positive. At the start of the reaction, there is 1 mole of X2 and no X is there. Now he is saying that as the reaction proceeds, the number of moles of X that will be formed will be given by beta. Thus, the beta equilibrium is the number of moles of X formed at equilibrium. So the reaction is carried out at a constant total pressure of 2 bar. Consider the gases to behave ideally. Now you have been given the value of R as 0.083 liters bar per Kelvin per mole, and you have been asked to do the questions. So it's question number 33 now that we have to do. So my dear students, the very first thing which many of you would have faced is like you would have thought of that this question is very lengthy, and if the question is lengthy you would have skipped this question. But again, this was the most tricky part for this year JEE Advanced. The questions that have been asked, these questions were not at all difficult. But it was like at least you should have this much patience that whatever is the question you should read it properly, try to solve each question in very step-to-step details. Now I'll show you how this question can be solved very easily. So he's saying us that the equilibrium constant Kp for this reaction at 298 Kelvin in terms of beta equilibrium is what? So you have to find out the Kp value. Now I can start it like this. It is given to me that x2 in the gaseous form is gonna give us 2x again in the gaseous form. Now if this is so, I can say that since, see, he has given us one thing. At the start of reaction, there is 1 mole of x2. So we can say when T is equal to 0, you were having it as 1 mole, and let's say this was 0. And at T is equal to T equilibrium. Now this we have to find out. And he says that as the reaction proceeds, the number of moles of X formed is given by B. So now we can say, let's say X formed is B. So I can say at equilibrium, so X formed will be B equilibrium. So how much of X2 would have reacted? 1 minus B equilibrium. So B equilibrium by 2 would have reacted. So the left out will be 1 minus B equilibrium by 2. And X formed will be B equilibrium. So what I was asked to write, Kp value, which is nothing but X in the gaseous state raised to the power 2 divided by X2 in the gaseous state. Now what can I write in this term? So actually what we have to do, rather than talking in terms of concentration, we have to say that P of X whole square divided by P of X2. This is what we have to find out. Now we know that what is partial pressure for a system. So partial pressure is nothing but total pressure multiplied by mole fraction. So let's assume the total pressure is Pt, and let's assume the mole fraction is, let's say, X for X, and for the another we can say partial pressure will be, so this is the partial pressure of X will be Pt into X of X, partial pressure of X2 will be Pt into X of X2. Now how can you calculate the mole fraction of X? Mole fraction of X can be calculated by number of moles of X, which is B equilibrium, divided by total number of moles, which is nothing, 1 minus B equilibrium divided by 2 plus B equilibrium. So it comes out to be B equilibrium divided by 1 plus B equilibrium by 2. So the same way you can find out the mole fraction of X2 also. Now if I substitute all these values, whatever I have written so far, I can say that B equilibrium divided by 1 plus B equilibrium by 2 into total pressure whole square divided by 1 minus B equilibrium divided by 2 by 1 plus B equilibrium divided by 2 into P total. So this is what we have found out right now. And if I ask you to solve this orange pen stuff, you can say Kp will be equal to B equilibrium whole square Pt square by Pt. It will remain as Pt only, and then you have 1 plus B equilibrium by 2 will get cancelled. So you have 1 plus B equilibrium by 2 multiplied by 1 minus B equilibrium by 2, and if you solve it you will get 2B equilibrium square divided by 1 minus B equilibrium by 4. And hence, to solve it further, to compare it to the answers that have been given to you, you can simplify it as 8 into B equilibrium square divided by 4 minus B equilibrium square. So this is what has been found out, the value of Kp. And if I ask you to look into the options, you can find out that option number B will be the correct option for this particular question. Now students, having done with this particular question, it's the time that I should move over to question number 34th now. Now question number 34th, again, since this is a continuous question of this paragraph itself, let me ask you to read this question. The question says that the incorrect statement among the following for this reaction is. So there are 4 options that have been given to you and you have to find out the incorrect statement. The first is, decrease in the total pressure will result in the formation of more moles of gaseous X. At the start of the reaction, dissociation of gaseous X2 takes place spontaneously. B equilibrium is 0.7 and Kc is less than 1. So now let us try to justify all these 4 options that have been given, and let's try to figure out which is correct and which is false out of them. So let me write down all the options one by one. So this is question number 34th. The first option says that decrease in the total pressure. So if you have total pressure as Pt, and if I am decreasing this total pressure, will it result in the formation of more moles of X gaseous? Now you can find out, see, pressure total. So on decreasing the pressure total, if I am decreasing it, my Q value can be written as number of moles of X2 multiplied by the total pressure divided by number of moles of X2. So this was number of moles of X whole square divided by number of moles of X2 into, again let's say, N total into Q. So this will be less than Kp, reaction will move in the forward direction, and hence we can say A option will be the correct option for this particular question. Now if I ask you to figure out option number B, for option number B it says that at the start of reaction the dissociation of gaseous X2 takes place spontaneously. Let's see, at the start of reaction you can say delta G is equal to delta G naught plus RT ln Q. Now when time t is equal to 0, you can say Q will also be 0. So delta G of reaction will be nothing but a negative value, and hence you can say that the reaction will be spontaneous. And hence option number B is also the correct option. I mean, you were to figure out the incorrect option. So neither A nor B is the answer. Third says that B equilibrium is 0.7. Now let's try to figure this out also. Now if B, suppose, let us take, if B equilibrium is 0.7, I will not ask you to solve out the value of B equilibrium. Rather, since he is telling us that you can take B equilibrium as 0.7, so you find Kp value, then that will be 8 into 0.49 divided by 4 minus 0.49, and this will come out to be something 3.92 divided by 3.51. So you can find out Kp value is coming out to be greater than 1. Since it is given to you that delta G naught of reaction is greater than 0, that means it is hence proved that Kp should be less than 1. But here this option says that Kp should be greater than 1. So we have got, we have got this as the correct option, because this is the incorrect statement that we have been looking for. So let's by the time mark option number C as the answer. Let's not forget about option number D. Option number D is Kp is equal to Kc into RT raised to the power delta Ng. So we can find Kc is equal to Kp divided by R into 298 raised to the power 1 only. So you can say here also, if you solve it, you will get Kc is less than 1, and this is what has been given in option number D. So please, my dear students, do not do this stupid mistake. Many times students do like this. They find out that okay, option number A, B, D all are correct, so they'll mark it as correct. Please do refer to this thing he has asked about incorrect statement. So out of 4 only, let's say option number C was incorrect. So mark this as answer, not all these things. So many times many students have got this tendency to do a blunder in the exam by marking these kind of stuff. So don't do these stupid mistakes in your exams. Be very, very careful while you are marking the answers. So now students, I think we are left with 2 other questions, which is question number 35 and question number 36. Let me first make you read question number 35, which I suppose is another paragraph question. Yes. Let me read out the paragraph for you. The treatment of compound O with KMNO4H plus gave a compound P, which on heating with ammonia gave Q. The compound Q on treatment with bromine in the presence of NaOH produced R. On strong heating Q gave S, which on further treatment with ethyl 1,2-bromopropanoate in the presence of KOH followed by acidification gave a compound T. The compound O is given to you. Now you have to find out. Question number 35 is what is compound number R, and another question is what is compound number T. So dear students, this question you might be feeling like this is a very pathetic question. So many things have been asked in one particular question. But again, I will ask you not to be afraid of these kind of questions. The only way how you can figure out these questions is to start solving the question by having patience and trying to write down in small steps. So let me write question 35 and question number 36 simultaneously. So starting with compound number O. The compound O which is given to us is something like this. It has been told to us that once it is treated with H positive in the presence of KMNO4. Now you should know this thing. Whenever it is heated with H positive in the presence of KMNO4, whatever will be the alkyl groups present on the benzene ring, let they be of any length, they all will get converted into carboxylic acid. So this will be compound number P. Now further, it has been said that once you add ammonia and heat the compound number P, then again this is a very simple thing. The COOH once heated with ammonia group, this will get converted into amide. So you can write CONH2 here and you can write another CONH2 here. And let's say this is compound number Q. Now to this compound number Q, if you move ahead, it has been given that to compound number Q, if you start adding bromine in the presence of NaOH. Now again you can say this is elimination of C double bond O. So you will be getting what? You will be only getting one NH2 here and another NH2 here. This is compound number R. And I think the first question was, question number 35 was the compound number R is. So this compound number R, as per you can see in the options, you will find that this is option number A. Now I can say that once I am talking about how to go from Q to R is nothing but Hofmann degradation reaction. Now after this we are asked that if this compound Q is made to be heated only. Now when two amide groups are there and you are asking them to heat away, then you can do one thing. There will be one benzene like this, and let me write it like this. You have CONH2, you have CONH2. So once you are heating it, there will be a loss of ammonia molecule, and as soon as there will be a loss of ammonia molecule, you can finally draw the structure something like this. You have CONH and you have CO. So this compound is compound number S. Now if I go further with the statement, this compound number S, as per the question, if this compound number S is treated with, first of all, let's say KOH, and then this is treated with CH3CHBr, COOET. Now you should all remember that if we are going to go from S to T, this is nothing but all the steps for Gabriel phthalimide synthesis reaction. So first of all, it is going to form N minus K plus the potassium salt of phthalimide. So this was phthalic anhydride. So this is phthalimide. And then if I do N minus K positive, that is nothing but the potassium salt of phthalimide. So once I have done the potassium salt of phthalimide, and if I ask you to heat it, the compound so formed will be something like this. So you have C double bond O, N, C double bond O. So this N minus K positive, you can say that this N will attack here, let's say with this C delta plus, and this Br will go away, so that you can have CH, and then you have a CH3, then you have COOET here. Now if I got this thing and if I ask you to do the hydrolysis, you will get phthalic acid, COOH, COOH, and then you will get aniline, which is NH2, CH, CH3, COOH. This is alanine. So this was the compound number T you were talking about, and if I asked you to look into the option, the compound number T was either glycine, alanine, valine or serine. So you can say option number B will be the correct option for question number 36. So students, this was all about how I help you out in solving this exam for JEE Advanced Paper 2 for 2016. Now I suppose you would have enjoyed the complete series. I suppose the questions whatever we have tried to discuss in today's lecture would have been important to you. For those who are watching this video as what they have done in the exam, so I would wish you all the very, very best for your results. And for those who are watching this video, let's say to prepare for upcoming exams, again all the best for all those students so that they can do all the well in their lives. So students, now let me take a leave from you people. By the time you take care, study well and be happy.